Hey everyone, it's David Bombal coming to you from the McLaren Technology Center here in Woking, England. I've been invited by Cisco to look at some of their newest security products. I've been told that there's a bunch of AI, but new firewalling technology as well, supposedly going to change the game. But let's see what it's about.
Before we click deploy, let's jump into the CLI. Apache 2 at the top, Metasploit running at the bottom. You can see at the top, you see a process is spawned. That process being spawned is our attacker leveraging the exploit to open a remote session. And then we use that remote session to steal something. So we're going to steal Alice's AWS credentials. So now we've stolen data successfully.
Hey everyone, it's David Bombal coming to you from a really cool location, back with Jeetu. Jeetu, great to see you again.
David, it seems like I'm becoming a regular on your show.
I like
this
that.
is like very cool. Thank you for having me.
No, it's great to have you here. I want to ask you, like developments in tech, what's happening? You're based in Silicon Valley. I'm not. For us that aren't, where's the world going?
Oh my! I think it's like universal right now, where people know we are experiencing such a profound shift in the world because of AI. It's one of the most significant platform shifts that I think we've experienced as humans. And the thing that's really interesting about these tectonic shifts that happen, the platform shifts that happen, David, is that in the short term, people grossly overestimate the effect, I should say.
Okay.
Right? Because so in the past year, the reality is your and my life hasn't changed that much since ChatGPT.
No.
Because it's been a good productivity tool, but things haven't gone upside down yet. But in the next 10 years, I think it'll be hard to imagine how we lived without this technology, and the experience will be so materially different.
The attackers have AI. So if the good guys don't use AI or leverage that, the attackers are just going to make things worse, right?
Well, I think the capacity and the potential for attackers to weaponize AI is non-trivial, and it's going to be very real.
Yeah.
And in fact, what that requires is that the defender not just handle security at human scale, but has to handle it at machine scale. And, it's one of those things where it is both a defensive and an offensive move.
Yep.
You don't have a choice but to use AI because the attackers are going to use it.
Exactly.
And you can use AI to stop the attackers far better than what you could do before. So therefore you should use AI.
Tom, great to see you again.
David, thanks for having me.
So this is fantastic technology.
Yeah, wait a minute. Are you having me or am I having you?
I don't know.
Yeah, but certainly we're both here at McLaren, which is a fun place to be, right?
Yeah, exactly. I mean, I was going to say fantastic technology.
Yeah.
But you have announced something.
Yeah.
I believe that, I don't know if it's fair to say, firewalls may be dead or something.
Well, I'm a guy that runs a very large, important firewall business, but I will say I've been working on firewalls my whole career.
Yeah.
Or the majority of my career. And I think there's an opportunity to reinvent what we think of as network security. And this is particularly important in this era of AI, because the tools that we have to build new products using AI are unlike anything we've had before. And the imperative to build new products is also being driven by AI, because the data center, which is the factory behind all this AI, is going through an explosive period of growth, like an order of magnitude. And so we can't just keep doing the same thing that we were doing before, cabling it up and hoping for a different outcome. Right? We got to think differently.
I mean, I've got a book here. I was told about eBPF. Has it got something to do with this?
It sure does.
So perhaps you can tell us, like, the new product that Cisco's announced, what pain points does it solve? What is it got to do with eBPF? And, why are firewalls perhaps not as good as they were in the past?
Yeah, okay. Let's start with the building blocks.
Okay.
What are the technical pieces that allow us to do the magic? And then I'll describe what problems it solves. First, and I'll argue most important building block, is eBPF.
Okay.
So what is eBPF? eBPF is an interface in Linux and increasingly in Windows that allows a user-based agent to peer into the heart of the operating system without actually being in the heart of the operating system.
Yep.
And so we see every system call, every function call, every I/O operation, every software process that's running, a very, very high level of visibility that was difficult or impossible to achieve before. And it's done in an ultra-efficient computational manner, and that when we run benchmarks on applications using eBPF, they can be 1% of CPU. So they're sort of invisible from a performance standpoint. eBPF-based solutions have become the de facto way of doing networking and security policy enforcement in the native public cloud. So one container talking to another container, eBPF is the tool that orchestrates that communication and says this cluster can talk to that cluster, but not this other cluster over here, right? Basic access control type of things.
So just to explain eBPF to me, it exists in the kernel in Linux, is that right?
So it exists in the kernel, but what it is a way to do just-in-time compilation of code that you're going to insert in the kernel. So, when we want to recompile a kernel, that doesn't work very well because either we have to open source the code or we're running a tainted kernel, right? And nobody wants that. So what do we fall back to classically? Kernel modules. But if I write a kernel module and the kernel module crashes, I take down the whole system. And that's probably worse than whatever I was trying to protect against in the system, right? So this is where eBPF came in. It's a way to safely, at runtime, extend the functionality of the kernel. That just-in-time compilation makes sure that there's no memory leaks, that there's no crashes, that there's no infinite loops. And so that when I push this functionality into the kernel, it's going to be safe, it's going to be low overhead, and at runtime, I can extend that functionality.
Is there a chance that people could write malicious code into the kernel now?
Yeah, absolutely. So anything that can be used for good can be used for bad. So one of the good things about Cisco Hypershield and the fact that we're running on the system and we're managing eBPF in this way is that we're not only using eBPF ourselves to protect applications, but we're actually monitoring eBPF usage in the system by other programs to make sure that they're not inserting malicious code using eBPF to attack you.
So when you understand the capability that we can see through eBPF, the deep understanding of the application, it allows us to make security decisions that, with that contextual understanding of the application, that are far superior than in the old days of firewalls where you're trying to guess it. Port numbers and packets on the wire, is this good or bad? Like, I don't know, you know, right? So that's one building block. Second building block is in the hardware itself. So a computer, I will argue a modern computer is built up of three subsystems. CPU, we all know what that is. A GPU is a graphics processing unit. Now, these are vector processors that were originally built to manipulate pixels, and you got a lot of pixels on a screen, so they can do a whole bunch of operations at one time. One clock cycle, ka-chunk, right, does thousands of data points. That same architecture allows GPUs to accelerate AI processing by like 1,000x, right? So this is why GPUs are becoming really, really important in a computer. There's a third subsystem. It's called a DPU. Data processing unit.
Not many people know what that is.
Correct. It's more buried in the infrastructure, but it's a really, really important piece of the puzzle because a DPU is the I/O device, and a DPU has evolved to the point where it's now a little system on a chip. So a DPU has cores, it has memory, it's got hardware for doing connection handling, encryption, TCP offload, all that kind of stuff. And you can think of it as a little tiny baby firewall on a chip.
And that could go on a network card or something, right?
It can go anywhere.
Oh, okay.
Right? It can go in a server. It could go into the network infrastructure. And it allows us to take this notion of a firewall that used to live at the edge and break it into 100,000, 1,000,000 tiny little pieces and put them everywhere. And so when you have this distributed system, it allows you to create much more fine-grained control that can leverage that application understanding that we talked about with eBPF. So the third building block here, there's eBPF, there's DPU hardware, and then the third building block is AI itself. Because in a world of distributed systems, let's say I could give you 100,000 firewalls or 1,000,000 firewalls. Exactly. I saw them wince, right? And so very hard to manage.
Exactly.
How do you manage 1,000,000 firewalls?
I can't even manage my own one.
Correct.
Like a single one.
Correct. Exactly. So my riddle is, how do you answer 1,000,000 firewalls? The answer is you don't. The computers manage the firewalls, right? And so we have built a new architecture. From the beginning, it's built to leverage the power of AI to bring a whole new management paradigm to bear. And I know it sounds like grandiose language.
Went into the nitty-gritty of it.
Yeah, exactly. Let's dig into it. But imagine a firewall that writes its own rules, that tests its own rules, that deploys its own rules, it lifecycle manages its own rules, and then magically while you're sleeping, it upgrades itself.
Bit of a worry about that, but I mean, hopefully you're going to address that as well, right?
Correct. So one of the lessons we've learned is that when you build a highly autonomous system like that, we've got to provision it in a way that it earns your trust.
Yeah, exactly.
Right? You're not just going to take your hands off the wheel and be like, car, take me home. No.
Yeah.
You got to earn my trust to show me that this automation actually works. So we earn your trust. I think in very short order, customers are going to be like, man, this thing is qualifying these upgrades in a way that it's so easy. I just say yes.
Yeah.
You know, good analogy is think about your iPhone. Do you remember, I don't know, 5 years ago, what it was like to update the iPhone or your Android phone?
Exactly.
You plugged it into your computer, you backed up all your photos, you backed up all your contacts. Okay, I'm all ready to go. Then you would do the upgrade. The reason why you went through that laborious process, you didn't trust the upgrade.
Exactly, yeah.
Right? Now that we're like, you know, when I think about like, when's the last time I upgraded my iPhone? I don't even know. Like, it just somehow I wake up in the morning and it's up to date.
Yeah.
Because I trust the update.
Yeah.
Right? So automation is really, really, really important.
Jeetu, I'm obviously here for a reason, and so are you.
Yeah.
You announced a product today. I don't want to spoil it, but I know there's an AI piece, but there's more than that, right?
Much more than that. I think, so the product that we announced today is truly, the name of the product is Cisco Hypershield.
Okay.
Right? I would say it is the most consequential product that we have announced in Cisco's 40-year history in cybersecurity.
That's a big statement.
It is a big statement, and it's actually a statement that can't be overstated enough.
So why, to say that, why is it so big? Why is it a big shift?
Because I think what we've been able to do is solve some problems that for decades we have not been able to solve in security, that have actually caused exposure points for us and made us very, very vulnerable against the adversaries.
Yeah.
I'll give you a couple examples. It's really hard to upgrade dated infrastructure.
Yeah.
But one of the big challenges we have with critical infrastructure, hospitals, power grids, financial services systems, is that they're all running on dated infrastructure. And it's the reason it's hard to upgrade kind of dated infrastructure is you have to bring it down to upgrade it. You have two change control windows. One might be during the holiday season at the end of the year. One might be in the middle of the year. If in the US, it's 4th of July and Christmas, right? And it simply isn't something that brings about agility and how you can go out and get rid of dated infrastructures. What do adversaries do? They take advantage of that, and they can then find a weak link in there and make sure that they can penetrate your environment. What have we done? We've said, that is a problem that we can solve with AI in a magical way. And so upgrades can be self-qualifying is the first thing that we're going to do with. The second big area is from the time that you actually announce a vulnerability to when it gets exploited is now getting down to single-digit days. And in fact, I don't think it'll be too far out, David, before this thing happens within hours and minutes. But it takes about 20 to 45, 49 days to go out and issue a patch and get a patch implemented.
We have no
and
hope.
Tested and deployed. So that window is a window of very high risk for companies.
Exactly.
Right? And so what do we do there? Well, we've actually solved that problem by saying, can you within minutes prevent an organization and actually have compensating controls that can shield the organization from a vulnerability and its exposure before the patch is applied, tested and deployed.
So is that on the edge devices, like on firewalls? Is it somewhere else?
Anywhere in the infrastructure. That's the beauty of it. We take security. The way that we've done is we've taken security, broken it into millions of piece parts, and put security in front of any workload that you wanted to put in front of. So if you wanted it in front of an IoT device, go ahead and do that. In front of an OT device, go ahead and do that. In front of a microservice and an application, go ahead and do that. Put it in front of a Kubernetes cluster, go ahead and do that. So that's what we've tried to do. And so that's the second big area that we've worked on. And the third one is you have to assume in today's day and age that the attacker is already in and your endpoint is already compromised. That is a safe assumption to make moving forward. When the attacker is already in, it's really hard to contain the attack from spreading when the attacker is in, because what do? They do lateral movement.
Yep.
And when we've seen hacks that have happened, when credit card numbers have been stolen, for example, they don't go directly to the credit card database. They might come in and then make multiple different hops. There was a recent vulnerability that the attacker made 48 different hops, and they stole 250 million credit card numbers. We can now solve this problem because we've got this a completely distributed, kind of enforcement point where you would be able to have the ability to contain the exploits and make sure that you can actually have segmentation policies dynamically applied to it. So it's automated segmentation. And that in my mind, these are like major innovations that were really hard computer science problems to solve that we are able to solve because of a core set of underlying technologies that weren't ready up until now, like eBPF, like hardware acceleration, like AI. And now that we have those, you can build things on top of that that you couldn't have even imagined a few years ago.
So you are applying, I'm assuming it's like a platform, is that right? And you're applying a policy across all devices or specific devices?
Yeah, we can actually, so not only do we applying a policy, what we are doing is we're taking security and breaking it up and almost melting security into the fabric of the network. And once you've done that, in front of every workload, you could go out and have some kind of an enforcement. And that enforcement can happen as a piece of software, which is eBPF. It can happen on a piece of hardware, whether a server or a top-of-rack switch. And you can actually make sure that that can build over time and they will all be coordinated. And that, in my mind, is not just a new product or a new feature. It is an architectural shift that was needed for the AI scale world. Because if you have these massive digital cities with billions of digital workers, the scale proportion is so different that you have to reimagine the architecture.
So do you see that defenders will now use AI? This product is going to write rules to stop, say, for instance, vulnerabilities that are already out there and do it automatically using AI?
Yeah, what this will do is it will not just write rules, but it will make sure that when there's a vulnerability and a patch has not been issued, what do you do during the moment of time and the patch has not been issued so that you can actually prevent that organization from that vulnerability being exploited during that interim period? Or if you happen to have an end-of-sale device or an end-of-service device or an end-of-life device, and that patch is never going to be issued, what do you do then?
Yeah.
Well, let's make sure that we can actually have compensating controls that can be stacked on top of each other so that you aren't in this kind of very crippled position of waiting until the patch is applied before you feel safe.
And Craig, you're the creator of Hypershield, I believe. You've got me reading this book, eBPF. Why do I need to read this?
So first of all, me and my team created Hypershield. Always give credit to everybody. But it did start with eBPF. So eBPF is a way for us to safely extend the functionality of the kernel. Today, the Linux kernel, tomorrow, even the Windows kernel. And what that allows us to do is things we could never do before. We wanted to bring networking and application security together.
Okay.
And we did that using eBPF because eBPF, unlike recompiling a kernel or building a kernel module, it allows us to safely extend the functionality of the kernel at runtime. And people will know about eBPF because every time you use Netflix or Google or Amazon, you're actually using eBPF without knowing it because that's how they do load balancing and DDoS prevention and a lot of things that we do classically in security. But we thought, what if we could take it to the next level? What if we could wrap the entire application into eBPF? And so now, instead of limiting ourselves to what we used to do in firewalls, which is looking at network traffic, what if we could understand every function call, every system call, every database write, every disk write, everything that an application does, and bring all that intelligence together? Build an actual graph of all of the dependencies that an application has. And then we took AI and applied it to that graph.
Okay.
And using that, we do a few things. First, we can autonomously generate segmentation rules. And we do that by learning over time the behavior of the application, just the way that administrators do. You know, when I want to microsegment an app today, I have to reverse engineer how the app works. What are all the dependencies? What does it talk to? And then I go craft firewall rules and I hope that nothing changes.
Or breaks,
Yeah. So we've moved that to a constant learning process with eBPF, where we assign identities to all the components, we track their versions, we track their communications, and then we build tighter and tighter controls over time using AI to automatically segment the application and prevent lateral movement of attackers in the network. So that's the first thing that we do.
Okay.
Second thing that we do is we look for known vulnerabilities. So within that graph, it's built on not just what we see, but also the SBOM, software bill of materials that we get from exploding an application. So we know all of the dependent libraries, like open source libraries that an application relies on, and whether they're actually being used actively by the application. So now I can take something like Apache is running in the system. It has a vulnerability. I know that this version is vulnerable, and I can identify that there's a vulnerability that we need to try to fix. The third thing is we look for just simply patterns of malicious behavior. So kind of classically, we use IDS, IPS to do this in networking, right? We create signatures of what attacks look like, and we match against network traffic. But imagine I could do that for everything an application did.
Okay.
An SQL injection attack, a privilege escalation, anything that the application does, I can put a signature on it. And since I can observe it in eBPF and I can modify or block it in eBPF, now I can do like IDS, IPS for every type of malicious behavior that an application may exhibit. So we've stopped lateral movement, we've stopped known vulnerabilities, and we've stopped unknown or zero-day vulnerabilities by looking for patterns of malicious behavior, all automatically, all AI-driven, based on eBPF combined with our graph analysis and our generative AI engine.
I've heard this term about a dual plane or something, data plane?
Yeah, dual data plane. So one of the things that I've learned in my career, so I spent a long time building SD-WAN products. And SD-WAN was an evolution in networking because we moved from real true embedded software to software-defined networking being applied on top of routers and eventually firewalls. And users weren't ready for that because the time it took to test every possible variation of software was a very long time. So what happens? It takes a year to test every possible permutation of the system. That means I pack a year's worth of features in the release. And that means that I've introduced a ton of different ways that it could fail when I hit the real world and have to experience this amazing variety of traffic types, policy combinations, feature combinations that exist. And so we thought, how can we fix this? What if we could somehow test this in the real world so that we could rapidly iterate on software? This is where the dual data plane comes in.
Okay.
So think of it like a digital twin. Every enforcement point in Cisco Hypershield is actually running two versions of the software in parallel. So what we're able to do is do CI/CD right to an embedded device. But the last stage of the promotion pipeline is the customer's own production network. But we're not disrupting their network. We're doing it transparently in this digital twin environment. So we actually mirror the customer's traffic between the current version of code and the new version of code. That means that with your traffic, with your combination of policies, with your combination of features, before you deploy the software, we're verifying with a high level of confidence using AI that it will work the way we expect it to when you upgrade. Then when you're ready to upgrade, we do a Kubernetes-style blue-green deployment where we move one flow at a time from exiting the old version of code to exiting the new version of code. So we got zero downtime, pre-qualified updates. That means when your next critical vulnerability comes out, you don't need to wait for a maintenance window and do a long testing cycle before you feel safe patching that vulnerability. You can have it happen automatically.
Craig, this sounds great, but have you got any examples of this doing something where it stops an attack or in the real world as an example?
Yeah, I mean, lots of high-profile attacks coming out recently. An example recently was XZ, which is an attack we can stop. But I think a more interesting one came out in February. There was a big, well-known remote desktop exploit that happened. And that remote desktop exploit allowed users to do admin bypass and get administrative control of the system. Now, this is an attack that was disclosed privately on February 13th, publicly on February 19th, and according to CISA, exploited by February 22nd. So you see that window shrinking further and further. We're talking 3 days before the attackers were able to exploit the vulnerability. And I think with generative AI, that time is going to shrink more and more and more and more. My team was able to, in 15 minutes, create a compensating control that could block that attack. So imagine it's announced publicly, and 15 minutes and 2 seconds later, you're protected from being exploited. We have really shrunk the window that the attacker has to get in and exploit this vulnerability.
I lost my mother in February of 22.
Sorry to hear that.
Thanks. And she was really close to me, right? And one of the things that one of my friends had told me at the time, because she had given me 8 weeks where we knew she was going to be gone, and she spent a lot of time with me. And one of my friends who had also lost her mother said, Jeetu, make sure you record a lot of the videos because you're going to miss her. You'll have a lot of pictures, but you're going to miss her because you haven't seen her. And so I recorded a lot of videos. And now there are moments when I'll actually sit back and I'll look at it. You know, I go back at the time when I was with her. Imagine, though, for my daughter when I'm gone. I don't think it's just going to be a unidirectional video. I think the machine learning models will be trained well enough on how Jeetu thinks and how Jeetu operates and how Jeetu might respond to something that when I'm gone, hopefully many, many years from now, and my daughter wanted to talk with her dad, and she was at an age where she might be open to taking more input than she is when she's 13, she might be able to have a full-on conversation with me. And I'll be there, and my video will look just like me.
Yep.
And my audio will sound just like me, and my ideas will be very much the way that I would have been. And she will have the benefit of being able to engage in a full-fledged dialogue, have me as a coach, even though I'm not alive.
To capture who you are, basically.
Capture who I am. And I think that is a profound shift in how humans operate, right?
Yep.
It's beyond having a productivity tool. And I think that what people tend to be is very, in the short term, they're like, well, this is going to go out and change the world. It usually takes a long time for technology to completely change the way that things are operating. But in the long term, it's hard to imagine all the things that are going to be radically different. And that will require that we rethink a lot of the assumptions on how we actually exist in society.
Jeetu, I have to address this. AI seems to be scary. Boston Dynamics, NVIDIA, I've seen like robots and all kinds of things. Do I need to be scared of AI?
I think as logical, responsible human beings, we should be scared and excited about AI. And AI can be weaponized pretty badly. I think when robotics comes into the picture, that can be weaponized in a really, really scary way. And I think you're going to need to make sure that security evolves and has controls that creates guardrails for AI so that it doesn't operate outside of human interest. And, as you start to think of AI having more ability to emulate emotion and ambition and vanity, that could be very dangerous. And
Exactly.
we need to make sure that we're constructing guardrails so that doesn't happen.
Our children are younger. Is the world going to be a better place, do you think? Or is it like Terminator type stuff a lot of people are worried about?
I am an optimist, and I think the world's going to be a better place, but I do think that we can't be oblivious to the risks that exist. And those risks have to be addressed proactively rather than waiting for when the risks manifest and then you say we'll figure it out, because by that time it will be too late, David.
And that's a problem with tech companies often,
That is
right?
the problem with tech companies. We always look at we are eternal optimists, but that optimism sometimes can get us into trouble. And so we have to make sure that we take a balanced view as we go into it.
I think the big worry that I heard from a lot of the audience in our previous video comes up a lot with whenever AI is in the discussion. I'm going to lose my job. I'm not going to be able to get a job. AI is going to replace me.
Look, I think it would be naive for us to think that there won't be certain jobs that will be affected. They will be affected, right? Today, AI is good at tasks, not jobs.
Yeah.
Will AI get good enough to go out and have certain jobs that we won't need people for, and then people can go to higher order jobs? Yes. Will that displacement cause pain and discomfort for people? Absolutely. Do we as a tech community have a responsibility for making sure that the reskilling happens for those people for whom the jobs have been displaced? Yes. And I think one of the irresponsible things that we've done in tech in the past is we've always thought about this as when there's a disruptive technology, you always take it as par for the course.
Yep.
You say, oh, that's just something that disruptive technologies do. And it's going to be, the upside is far greater than the downside, so we don't have to worry about the downside. But it's never always a sum total. It's actually the people that have been affected negatively are real. And we need to make sure that we keep them in mind. And then the upside, of course, is very real as well. And you have to keep it in mind. So in my mind, yes, there might be some risk of jobs, and we have to make sure that we get ahead of that. Yes, there might be things that where, AI could be massively harmful, and we might have to even get ahead of that from even deeper collaboration between the public and private sector, which is now starting to happen in a very encouraging way, so that regulations can be put in place. You don't want to over-regulate, but you don't want to under-regulate. I think these are all kind of hard problems in society that need to be figured out, that I don't think we all have answers for that are crystal clear yet. But if we don't think about the downside, and if we just have our rose-colored glasses on, I think we will do some damage in society. And we have to make sure that you look at both sides of the equation, especially if you're starting to deliver these technologies to the market, which could have a downside effect.
A lot of talk about AI. I think the two biggest concerns people perhaps have is, can I trust it? And secondly, will it take my job away?
So to the first question, can I trust it? Well, the attackers are using it.
Yeah.
So no, we can't trust everything it does, but we have to use it to stay ahead of the game. One of the powers of Cisco Hypershield is we've introduced this concept of a dual data plane that verifies changes before we put them out. So imagine a solution that's just using AI to recommend firewall policies for you. You hope that the AI got it right.
Exactly.
And when you put it in. In our case, when the AI recommends a policy, we place it in our shadow data plane, and we actually test it in your production environment in a digital twin transparently, so that we can tell whether it actually achieved the outcome that AI intended. If it did, we give you the confidence that we've pre-verified that AI recommended the right policy. If it didn't, we've built a feedback loop that trains AI on how to resolve that and make better recommendations in the future. As for, is it going to take my job away? I spent a long time in SD-WAN. And I remember when I first created SD-WAN products, network administrators saying, are you going to put me out of a job because you've automated away all of the QoS work that I used to do? Well, did we put network admins out of the job? No, we didn't. What we did was we freed them up from menial tasks. And by the way, micro-segmentation and patching applications, those are pretty menial tasks. And we freed them up to spend their time doing more important, more innovative things. And at the pace that cybersecurity is moving, being able to free up our SOC admins and our network security admins to focus on what's important and not focus on resolving the problems of the past is really going to enable them to be more productive at their jobs.
Got a daughter of 13. I've also got a daughter who's 13 years old.
Oh, we should do Playdate, man.
That's right.
Yeah.
What would you advise them to study or do? Because AI is changing everything.
I actually think knowledge will be less valued in the future.
Interesting.
And I think what will be valued more is the quality of questions that you can ask so that you can discover the insights based on the quality of questions. So what I would actually hope that she learns is knowing the right questions to ask, because that'll actually get her to be smarter in the next stage than actually having the physical knowledge, because knowledge you can get access to.
Yeah, so like when we started, you had to memorize stuff. Now you just Google it.
Now you just,
And now it's next level.
That's right. And by the way, people will say, oh, that's not really good because you need to have knowledge. Like when calculators first came out, people didn't want to use them because they thought the math skills would go back. And then they were able to do more because of calculators. And I think the same will happen over here, is you will be able to get higher order functions operating in your brain because you're not focused as much on the other pieces, and you can use your brain power doing other things.
All right, here we see Cisco Hypershield running inside Cisco Defense Orchestrator. We've got one virtual firewall, one security agent, and 2 workloads that we're monitoring. While the system is running, Cisco developers are writing code, pushing it through CI/CD, and we've got the security agent that's learning about your workloads and your applications and how they perform. So over time, you're going to see a couple things happen as we refresh the screen. One, you're going to see that we have a new version of software that is currently being tested in the environment. And 2, you'll see that we have found a vulnerability inside Apache 2 that has a CVSS score of 7.5, which is high severity. So let's take a look at the upgrade process first. We pushed this upgrade using CI/CD into the digital twin or shadow data plane that's running inside your environment. You can see there on the right that it says it's testing, and you can see the status and the history. Now, if we click into the results, you can see that this has failed verification. We have very low confidence that this would work in your environment. We're not going to recommend it to you. You can see the list of test cases that failed. Perhaps the most concerning, we saw 8.7% memory growth, which looks like a memory leak. So now this failure was automatically reported back to Cisco so that we could fix the issue. Developer could make a patch, push it back into the code repository, back through the CI/CD process, and then over time, that upgrade will make it back to your shadow data plane, and you'll see that we have now a new version that is being tested in your environment, and this is the version that has the fix for that issue that we found during testing. Now, testing goes over a certain period of time. We want to try and evaluate how much code coverage we're hitting, how much of a diversity of traffic we've seen, how many of your policies we've matched, to try to really get as high a confidence as we can that this will not affect you negatively when you roll it out in production. For the purpose of a demo, of course, we're going to do this very quickly and run through verification very quickly to reach a high confidence score, because we want to make sure that we're not sitting here for days waiting for it to complete. So we refresh in, testing has completed. We see that this has been tested by Hypershield. Confidence is above 90%, so we're going to recommend that this release is good for you to deploy. We attach the release notes directly in line. We give you a list of all the test cases that we have calculated to show that it's working well in your environment, and we show any deltas that exist in the policies that you have configured between the 2 versions of the code. When you click Update Now, It's a simple Kubernetes-style blue-green promotion, one flow at a time, moved from the old to the new. And then once everything is running on the new version, we can upgrade the shadow. So that's it. Zero downtime, pre-qualified software upgrade. Now that second piece, remember that we also found a vulnerability that existed inside your environment. Now there's two ways you can find out about what's in an environment. One is what we call the SBOM, software bill of materials, where you see the package list below. Here you also see that this is being used actively by the process. So we're not only relying on the SBOM, we're coupling that with the data we have from eBPF to know that Apache is actually being actively used and could be exploited in your environment. If we click into the vulnerability, you'll see that you get a description of what is the vulnerability and how can it be exploited. And then you can ask AI any questions you have about what it is, how it's exploited, how it's patched. We'll give you lots of information. We'll give you helpful links to learn more about the vulnerability if you want to educate yourself on this. Before we click deploy, let's jump into the CLI. Apache 2 at the top, Metasploit running at the bottom. You can see at the top, you see a process is spawned. That process being spawned is our attacker leveraging the exploit to open a remote session. And then we use that remote session to steal something. So we're going to steal Alice's AWS credentials. So now we've stolen data successfully. But if we go back to the UI and we click deploy on the distributed exploit shield, that distributed exploit shield is going to go use eBPF to block this from happening. So if we catch an attacker trying to use this RCE to launch a process, we will intercept it and block it. And you'll see this as we run the Metasploit again on the same server, again, Apache 2 at the top. You see that process get spawned and immediately killed. That means that the attacker has been blocked from exploiting the vulnerability. This is confirmed below in the Metasploit session, where you can see that the exploit was completed, but no session was actually created. So in advance of the user being able to patch Apache 2, we placed that distributed exploit shield. We blocked the vulnerability from being exploited. And then once you upgrade, we pull that patch out.
Jeetu, we're out of time, unfortunately, and I'm getting shouted at. It's great to see you.
Such a pleasure.
Thanks so much for sharing.
Take care.
Cheers. Really want to. Thank you. Thanks for sharing.
Always fun, David. Thanks for having me.
Thanks.
Yeah. Okay. Take care.
Thanks so much for sharing. Really appreciate it.
Thanks. Great to be here. Thanks for having me.